Hello, everyone, and welcome to the GSI podcast. I am Dr. Wayne Archibald, your host, and today we are diving into a fascinating topic that's changing the way that we view waste. It's waste to energy technology. But before we get started, I want to remind you to subscribe to our podcast and follow us on YouTube and Facebook to stay updated on all our exciting episodes. So today, as our first guest, we have Mr. Colvin Manning from Bermuda. He is the Electronic Instrumentation Technician Supervisor from Bermuda, and he works for the Ministry of Public Works and the Department of Works and Engineering. He has over 30 years, correct me if I'm wrong, Calvin, over 30 years of experience in waste to energy, and that's what we're going to talk about today.
Yes, that's
Uh,
correct.
yeah,
That is correct. Yes.
so waste to energy is not only an innovative solution to our growing waste problem, but also a source of sustainable energy. So today we're going to explore this technology, its impact on the environment, and how transforming the waste management landscape can really impact a country's economy and so on. So thank you very much for being here, Calvin.
Yes. Thank you for having me. Um, so as you said, yes, I have 30 years plus of into waste to energy plants. Here in Bermuda, our plant is called Tynes Bay Waste to Energy Plant. We got our name changed several years ago because we used to be Tynes Bay uh, Waste Facility.
Right.
And so we changed our name because we was producing power for ourselves as well as sending it out to the grid. But we did not emphasize the energy part of it. So now we have a new turbine to our collection, and we also power an RO plant that is just down the road from the actual waste to energy plant. So we do a good bit, and we have been innovative. We're kept up with technology, and it is very interesting. I'm seeing uh, the boiler being modified, new turbine being installed, commissioned, new switchgear for the turbine had to be installed and commissioned, and multiple tests done throughout the whole transition.
Okay. Well, I had an opportunity to visit you in Bermuda, and we had quite an extensive tour of the plant and so on. But before we get into talking about like the technical details, right? We really want to
Yes.
speak to most of the people out there who don't really understand this technology, who doesn't, who are not engineers and so forth. So
Yes.
let's begin by our conversation by explaining just the basics of the waste to energy technology. And then from there, we'll go into discussing the process and how it converts waste to energy. So let's,
Yes. Okay. Not a problem. So basically, we used to do landfill, and our landfill was getting overrun, as we could break it down. It was filling up too fast because Bermuda's was expanding. We had a lot of growth in so many years of the population, people, work people coming in from overseas and staying. It was a lot. And you can tell how wealthy or how, what can I say, how, how fortunate the country is with just looking at its waste. And so you can see the population boom, people importing stuff. And basically, so we was taking all that waste into Tynes Bay. And at one point, we couldn't shut down for more than both streams for a week and the trash would pile up super quick. And we didn't have a contingency plan in place to deal with all of that. So we had to quickly fix one boiler, start it up, and then continue on to the next boiler. But we do have a recycling program which sort of helped us along. So tin, bottle, glass was taken out of the stream, and that was sent on to what is called our MRF plant, and that is our recycling plant. And we took some of the stuff out of the waste, but we could have taken more stuff out. But at the present time, by law, this has not been put into place yet. But I'm hoping it should be before I retire.
Right, right. So just to be clear, so Bermuda does not have a landfill. You used to have a landfill,
Yes, that's
uh,
correct.
and uh, now instead of having a landfill, all of the waste gets transported to Tynes Bay, is what it's called.
Yes, Tynes Bay Waste to Energy Plant now.
Okay, and that's where the waste is separated.
It's broken up, it's separated somewhat. The metal's taken out, what people bring in.
Right,
Then we mix the waste so we can get our what is called our calorific value up. So we just don't put in like into the boiler. We don't put in like a whole lot of paper or plastics at one time.
right,
We mix it with wood, lumber, and different materials. Sometimes the trash is wet. We have to dry it first. And we have what is called preheaters in our boiler. So when it
okay,
goes down to the feed chute, we send steam through that preheater. And that preheater somewhat dries out the wet refuge. We call
right,
it refuge. We don't call it trash. That's our
okay,
fuel, the
right. The
refuge.
refuge, right,
The refuge, yeah. Other people call it trash. That's our fuel. We call it refuge.
okay.
And that's how we dry it out to a certain extent before it actually gets inside the boiler and starts to burn.
Okay. So that's basically how it works. It goes from the landfill that you used to have into the waste facility plant.
Yes.
It's dried, then it goes into the boiler, right?
So sometimes it sits for a long period of, well, not a long period of time, but if we have a shutdown, that means that the total plant is shut down and we're doing maintenance. We stockpile it inside the boiler. I'm sorry, inside the bunker, which we have a tipping hole where the trucks come in. It's weighed, then it comes into the tipping hole. It gets dumped out either into the bunker, or if it's wood waste, it gets dumped onto the floor. So a payloader or a tractor pushes it into the bunker or pushes it into the Lindemann shear, which is another part of the process that takes like 16-foot lengths of lumber and chops it up into manageable size pieces. So we chop it up into between 4 and 6 feet long, and then we mix that in with the rest of the refuge, and we put that in one pile, and then we use that pile to feed the boilers.
So let me ask you. So how much waste do you how big, how large are the boilers? Like how much waste do you need to go into each boiler?
So,
Or what's the
uh,
minimum amount of waste that you need?
so our boilers are rated by tons per hour. So we can burn 6 tons of refuge every hour. So each boiler is 6 tons an hour per stream. So that we can burn 12 tons of refuge in 1 hour. And that's a continuous feed of refuge into that boiler. And we burn 24 hours a day, 7 days a week. So we burn roughly for 4,000 hours. And then we have what is called a shutdown for inspection. And we go in and inspect different things on the boiler tubes, the wrapping system, stuff like that. not to get too technical
Right.
with things right now. But yeah, we do inspections, we do blow-downs, different things, because I know a lot of people that's listening to this are probably not engineers and or power engineers or electrical engineers, so they wouldn't understand these terminologies.
Right, right. But we can use them sparingly for those who are
Yes,
engineers and who understand the technology.
yes,
So you've told us about the type of materials that you use in the waste to energy products, about the recycling, about how you prepare the materials before they go into the boilers and stuff like that. So once the materials, the refuge, as you call it,
yes, yes.
goes into the boilers, what happens there? Give us a step by step as to once you burn all this trash, basically the refuge,
The
sorry,
refuge,
right?
yes.
What happens and how do we get to the point of actually producing energy and sending it onto the grid?
Right. So let me break this right down to basically we have a large tea kettle. So when you put water in a tea kettle and it boils, and you have various different types of tea kettles. One of them particular that we're going to use is one that has a whistle on it. It blows and it goes real pitch high. So when the water is boiled, let's say you're in your bedroom, you left it on in the kitchen, you would know when the water is hot, when it's boiled, because the tea kettle will whistle.
Right.
So basically, we have our boilers is a large tea kettle, a massive tea kettle. Only thing is we don't let it whistle. So we have a lot of tubes inside the boiler, and those are our water walls, which produce steam. And the steam, we can send it various parts of the plant, as well as we have a what is called a steam turbine. That steam turbine is connected through a gearbox, which turns a generator, and that generator produces our power, and that's what we use to power ourselves, as well as to send that extra power out to the grid. So we get paid from our electrical provider, which is that's what we call the grid, the electrical provider,
Right.
and they pay us per kilowatt hour what we send to them,
Oh.
which is a different rate that what we buy from them when we have to.
So basically, you you produce energy. Tell us first how much energy approximately is produced from this waste to energy plant.
So presently, right now, we have a turbine or a generator that can do I think it's 6.8 megawatts. That's a lot of power.
Right.
So how it is when we start up, the steam has to be at a certain temperature and pressure. Once we warm up the turbine, we warm through the turbine with the steam, then we can open the stop valve and slowly wind that turbine up. And that turbine winds up to turn the generator, the new one is wound up to 5,500 RPMs, I do believe, if I'm not mistaken. Our oil generator used to wind up to 6,000 RPMs and going through the gearbox, and then that turned the generator. So we produce roughly 5 to 6 megawatts of power. So we supply ourselves first. So we take up what is called in-house load. So all the motors and everything that is running the plant, we take that power and start using the power that we generate to supply ourselves first before we start to what we call export. And we use roughly about 1.2 megawatts of power. And if we, so we also connect to our water plant. And so if the water plant is on, it's an RO plant. So if the RO plant is running, we also take up that load before we start to export. And the RO plant runs basically for free off of the refuge. We run for free off of the refuge. So long there's a steady stream of refuge coming in, we have no issues, and we don't, as long as we don't trip. Or there's a major fault with the grid that we feel it, meaning the plant sees it and it tries to pick up that load, that fault, and tries to run that as well. But very seldom we have faults like that. But there can be a fault like that. It's been several since I've been there that has actually tripped us offline and actually sent us into what we call black, into darkness.
Okay. I can go two different directions with this, but I want to just go with the flow of the conversation right now, right? So once you produce this power within the waste to energy facility, you supply your own power, you supply power to the other plant, and you export the rest onto the grid. So
Yes.
from a policy perspective, right, what
Yes.
kind of regulations are there that would help to promote the use of the waste to energy? Like when you sell it to the, I'm assuming you're selling it to the utility, right?
Yes.
And then do you also, is it enough to, well, let me ask it this way. What kind of policies are there? How much do you sell it to the utility for? And whenever there's a shutdown at the plant, right?
Yes.
How much do you spend buying back power from the utility? Is it a one-to-one ratio, or is it you buy back more than you?
No, it's not a 1-to-1 ratio.
Right.
The utility buys it from us for a certain amount of money. I'm not going to speak to the
Okay.
to that money per kilowatt hour. That's how it's done. The utility earns the grid, so we have to take a smaller portion per kilowatt hour. When we send it to them, they pay us a smaller portion. Also, roughly per year, on a good year, we can make in the vicinity of roughly $3, possibly $4 million of revenue that is paid to us from the utility. And it's all depending on how much material you have, which is the refuge, and the quality of your plant, meaning that you're up on your maintenance. If you have 2 streams, you can bring 1 stream down, do maintenance on that, still run your turbine off of your 2nd stream so that you are continuously producing power to sustain yourself as well as to export to the grid. So you make money on your tipping fees. When the trucks come in, go across the Ray Bridge, they pay so much money per ton. So we collect that money. Also, we collect money for producing power. So just on the producing side of it, we can make roughly between $3 million to $4 million per year on a good year.
Okay. So continuing on with the policy discussion of it, which I think that most governments would be interested in.
Yes.
How does how do citizens of Bermuda, the residents, both residential and business customers, how do they benefit from this waste to energy plant? Do they see a reduction in
Electricity
the
bill?
electricity bill?
No.
Yeah, tell us. Let's go a little deeper into that. Yeah.
Okay. No. The residents does not see a reduction in price per kilowatt hour to them. It's being sold from government to the utility. The how we see the price, not the residents, how government sees the price go down is when we power our own plants. So when we power our own plants using the refuge, we do not have to pay a utility bill. That utility bill should be zero. And that's how we see that
When you say
on
when you say we,
government side.
oh, on the government side.
On the government side, yeah, not
Okay.
on the residential side.
So basically, I would expect that there's more than one way to look at this. The citizens, they don't get a reduction in their electric bill because of the waste to energy plant. However, there may be some other benefits
Yes.
to having the waste to energy, right? So let's highlight some of the other like environmental benefits of the
So,
technology compared to the traditional waste disposal methods that you have in
okay.
Bermuda.
So landfill, it's takes up a lot of space, as well as you can have when that refuge is decomposing and it's packed down into the earth. It produces methane gases and hexane gases, and that is very volatile. And you have what is called spontaneous combustion on the landfill, and it starts a fire.
Right,
And
right.
that fire is deep rooted and very, very hard to put out. It takes at least 5 to 6 days to put out a deep rooted fire on a landfill and contain it. So when a fire breaks out, you cannot have nobody coming to dump onto the landfill. They have to hurl their trash, because that they call it trash. We
The
call it
refuge, the
refuge.
refuge.
Yes.
Right.
They have to hurl their stuff until we get that under control. So that was one of the causes that we went into the direction of incineration. The other environmental impact was when you do incineration, you reduce that amount of refuge down to a very small amount. So we reduce it down to roughly a third. So, and on top of that, uh, we get a, what can I call it? So we can stop landfill, as well as we produce what is called ash block out of that ash that we get from the incineration. So we sift it and we use it for process. So we do land reclamation. So down at our airport, we can do, we have built up our long-term parking, built up the coastline where we take our cars and trucks after they have been fully used and are no good, and we use that to reclaim land.
Oh, I see.
Uh, and that's a major impact. So we reduce, reuse, recycle,
Right.
reuse. That's what we do.
Okay. Are there any specific challenges or concerns about waste to energy that we should be aware of?
Um, Everything, no matter what, it needs maintenance. You have to stay on top of your maintenance, just like a car. If you let the tires go bald, you will get in an accident. If you don't take care of the brakes, and when you go and put your foot on the brake to stop the car's going to keep on going. So you have to do maintenance. Once you are up on your maintenance, your plant or your facility will last longer.
Okay. So,
So you need trained personnel to be in the specific veins of jobs that is required to run a waste to energy facility. They have to be trained. They have to be the best of the best. You
right.
you can't get somebody who is lackadaisy. You need eager people who love their job, and that comes a career.
Hmm. So, talking about jobs, right? Uh, I want to get back to that. But before I talk about the jobs that could be created as a result of waste to energy, I want to ask you because we have Jamaica, Barbados, Trinidad, we have the smaller islands in the OECS, St. Kitts, Nevis, Antigua, Grenada, Dominica, so on and so forth.
Right.
So they forgot, these islands are a different range of sizes. So in terms of the scalability, right,
Hmm.
and the feasibility, like how adaptable is the waste to energy technology for different regions and waste management systems and so forth?
So waste to energy is very adaptable. First of all, you need a large area uh, to put the plant. You need to do a feasibility study. So you need to also do a study of what type of waste do you put into your landfill, how much you put in per year to that landfill. If you have recycling in your in your area, in your island or whatever, know what type of recyclables you can make money off of to reduce, reuse. That's the way to go.
What
The
about
other
this?
thing,
What about the smaller islands, right? Bermuda, if I remember correctly, Bermuda is about the same size as it's smaller than Saint Kitts, I think,
Bermuda
right?
is 21 square miles long,
Right, right,
and it is the widest point is a mile and a half wide.
right. So
So we have a
how much trash do you generate? Do you always
we
have enough trash to keep the waste to energy facility going?
yes we do. Um, there is basically
Oh,
everything to Bermuda
refuge.
is imported. Yes, refuge.
Right.
Basically everything in Bermuda is imported. We have no facility here that produces stuff to export, like to produce a car or a bike or something like that there. We don't do that. We import all our vehicles, all our bikes, trucks, cars. We import everything. Food, clothing, everything is imported. Um, so everything is in a crate or a cardboard box. And there has to be somewhere to dispose of that. Even fridges. We take the gas out of fridges and freezers and stuff, and we reclaim that and we send that overseas as well. Oils we send overseas. Cooking oils, we use that and put that over the refuge, and that burns. Um, we don't burn tires. We don't burn tires. Um, Also, we have what you can call it. We have a sewage facility that we power that facility as well.
Right.
So that facility also runs for free. So sanitation trucks come in, bring their sewage, we process it, take the grease out of it and stuff like that, and then it is treated and sent out.
Oh, I see.
So
Okay.
we do quite a lot. We do quite a lot from waste
Okay.
to energy.
So, in the previous segment, we touched on the environmental benefits of waste to energy. And I want you to also discuss, because a lot of critics of waste to energy sometimes raise the concern about air pollution and emissions and so on from the waste to energy plant, right?
Yes.
Can you address these concerns and discuss
Yes.
like the measures in place to minimize the
Yes.
environmental harm? Yeah.
Yes. So we have a technology that comes from out of Europe, which is the best technology. All of this technology comes out of Europe, out of Germany, Switzerland. They have mastered waste to energy plants. So we have what is called SO2 gas, HCl, dust. So the environmental authority gives us a range of where how much particles we can put out, and it's done in ppm, parts per million. And if we exceed that, an alarm goes off inside the control room on the what we call the DCS, which is called also the human interface. So we have ranges where we can set. So if we have a dust issue, we can address it immediately. And if we can shut that boiler down, so if let's say the dust level, let's just throw a number out there, it went about 30 parts per million, and it went over, and it stayed in alarm for an hour, and we tried every measure to get that dust level down, and it did not go down. So we have to straight away inform the environmental department that we have an excursion. So this is where it's at. We have 12 hours to shut the plant down. You just can't go and hit a stop button and everything just stops, or turn the key off and everything just stops. So we have to slowly bring the plant down, slowly release, divert the steam to the startup manifold, and then we can shut the boiler down. And then after it cools down, and it takes roughly 2 to 3 days to cool the boiler down, because this thing produces a lot of heat. Cool that boiler down, then we can go inside and inspect and see what has taken place. And 9 times out of 10, what we have on the back end is called an electric static precipitator. That's what removes all the dust particles out of the stream of heat that goes out of the boiler. So how this works, basically, back in the day, we used to burn trash in our backyard in a steel barrel. Push all the paper in, light a piece of paper, got some wood in it, and after you light it, every now and then you'll see a piece of paper start floating up in the air, still got some embers on it, and it will, float up pretty high
Yeah.
and drop either in your neighbor's yard or somebody else's yard, depending on which way the wind is blowing, and you get smoke from it. Well, this technology, what we call the ESP, actually stops all of that, and it captures all of the dust particles, some of the smoke. It captures all of that and contains it. And a wrapping system, it's basically like a giant spark plug, and it produces roughly 80,000 volts, and it sparks, so it charges the particles in the air, either negative or positive. That sticks to some plates. Then the wrapping system comes along and knocks those plates, and that stuff drops down onto a conveyor belt. And that's what we call fly ash. And we collect that and take it back into the plant, and take it down to what we call the quench tank. It goes into water, and that quenches that hot paper or whatever it is, and then it goes out into the ash bunker. That's one part of it. So we have to also mix chemicals to sample the gases in the stream. We also have sniffers, and that is recorded 24 hours a day. So we can go back to any point in time and see when we had an alarm, and when that boiler went into alarm and we tried to control it, couldn't bring it back down, and then we trend all of this stuff. Everything has a trend, and we can shut the boiler down safely without any damage.
Okay.
And the stack is so high that 9 times out of 10, when we do a startup, a cold startup, we make sure that the wind is blowing offshore. So if we have an issue, anything that is going out of the stack is taken offshore, not on top of people's roofs, because in Bermuda, how we build our homes, we have a tank underneath our homes that captures the water from the roof. All our roofs are painted white, and that captures the water, and we put it into our tank. So we pump our own water. So we do our own water conservation, each household. So that's another thing that we have to be
to be mindful of, right?
to be mindful of.
Yes. Okay. Well, I
Yeah.
wanna get to two more things before we wrap up here, right? So,
Okay.
like when we're discussing these environmental impact and benefits, what role do you think that public perception and education play in the acceptance and the success of these waste to energy initiatives?
Yeah.
Right?
So a lot of the public does not know. They think they just bring the trash and we have a big bonfire, the refuge, and burn it. It is a controlled burn, and you need to be educated, skilled in what you are doing, no matter what. So a operator, what we call a power engineer. So you have different levels. You have fourth class, third class, second class, first class. First class is like a chief engineer. So we have to have skilled people at the controls.
Right.
Also, we have to have maintenance people in maintenance in case there is a steam leak, in case there is a water pipe that breaks or something like that, to do the maintenance on the boilers, on chain conveyors, different things like that, drag conveyors. We also have a blow down that blows down the economizer. So a lot of air gets put into the boiler and compressed air, and that compressed air is up to 9 bar or 7 bar, and what we call soot blowing. So we blow the ash off of the economizer tubes down, and that gets collected, some of the fly ash, and it gets brought back into the boiler, into the to the quench tank. So there's a lot of moving parts, to operate a plant. You need electrical people, people who can read a schematic, that can troubleshoot live stuff as well as stuff that is offline or been locked out and tagged out.
Right.
So you can't be a person that is nervous. Also, you have to be calm, cool, and collective, because when stuff is blowing off and people are in chaos, you have to be the cooler head to focus on what you are doing so you don't get hurt. Because the pressure of this boiler is 750 pounds per square inch
Oh, 750
inside of these
psi.
tubes. Yeah.
Right.
As
Yeah.
well as the steam gets up to 400 degrees Celsius.
Right.
So if you have a leak in a tube, you only hear it. You cannot see that steam because that steam doesn't condensate within 6 inches or 12 inches of that hole or flange that is leaking. You only hear it. You don't see it.
I,
So you have to be very knowledgeable of what you hear and see so you don't get injured and you can make it safe for that problem to be addressed in a timely manner.
I'm telling you, I remember when I was there and we were walking through and we saw the boilers and the flame and how hot it was. And I was
Yes.
thinking to myself, man, it must be really hot in hell, man.
Oh,
You know, we
yes.
really have to really have to live our lives in such a way such that we don't have to end up there, you know. But
Hello. Absolutely.
I'm telling you,
Absolutely.
man. But yeah, but you do you think, right? Because all over the Caribbean we see the same problems. Like we have landfills all over the Caribbean. Even in the Virgin Islands, we've had some fires at the landfills recently that lasted like days. You know,
Yep.
so it has adverse health impacts on people in the surrounding communities.
Yes.
Uh,
Smoke
with
inhalation,
oh yeah, yeah, especially people with asthma and stuff like
asthma and
that,
stuff
and
like that,
those
hay
kind
fever,
of
allergies.
devices. Yeah,
It's a serious thing.
yeah, we see the same thing at Riverton. In Jamaica, there's a problem with the waste to energy. In St. Kitts, you know, I can only speak for what I know, but I know several of these other islands really have been talking about for a long time about pursuing waste to energy and doing something with the landfill. Uh,
Yes.
you know, so why do you think that governments across the region, you know, just briefly, because we're going to wrap up soon, have been so reluctant to pursue these waste to energy technology initiatives? And do you see any promising collaboration between maybe government, industries, environmental organizations that can advance waste to energy projects on a much larger scale?
Right. Like I said, first of all, you have to do a feasibility study and whatnot. You have to know how much refuge you actually produce. Also, there is another thing that can be done as well. Let's say smaller islands can put their refuge on a barge and bring it across because the islands are pretty close down there. Um, and you could bring it across to one island that has the waste facility um, plant, and you charge them for their waste that they bring to you. So you can sustain yourself. So it's like how can I say, a government to government. They can work that out through policy and whatnot, as well as things can go public private to facilitate getting that waste to energy site, getting that technology brought into that country. You can go public private. You can go government to fund it, or even two governments and a private to fund that facility to get it built and get you guys up and running.
How much do you think a facility would cost in 2024 on the size that, you know, on the scale
At
you have
Times Bay
in
has.
Bermuda? Yeah.
So right now in Bermuda, um, we had got a quote, I think it was 3, 4 years ago, for one stream now. It's going to cost us roughly 140 to 150 million dollars.
Oh, US
for a
dollar.
single stream. That's a 6-ton stream right now. But also, it's well worth the money because you cannot continue on doing landfill.
Right. It can't continue forever.
You can't continue.
Right. Right.
You have to change with the times, and this way, doing a waste to energy plant, you can put back into your grid good electricity. You can start taking stuff out of your landfill and using that as your refuge, as well as when the refuge trucks go around to collect the refuse from each household, that can be put back in. So
Yeah.
you can start to reduce your landfill and get rid of it. We
Right.
also can burn horticultural waste. So you chop down your trees, you send it to the landfill dries it out to a certain extent, let it rot down. They can make soil, what we call compost. That can be sold back to the public at a cost, and the big roots from the trees that does not rot down quickly, that can be brought to the incinerator plant and be burnt.
Yeah.
So you can get more energy from that as well.
Right. We're not trying
So
to cut down any trees though.
no,
We
no,
gotta
no,
plant
no.
trees.
Right. So like people when
Right.
they cut their hedges and stuff,
Right.
pull
Right.
up cane grass and stuff, that can be used for compost, or when they take it to like our landfill, what we do with our landfill now is strictly horticultural waste. That's it. That's the
Okay.
only thing
Okay.
that goes to our old landfill is
Right.
horticultural waste.
Because that add back some kind of nutrients to the soil also, right? And
Yes,
so
good
forth and so on.
fertilizer.
Right,
Very good
right, right,
fertilizer.
right, right. So we've really had a good conversation. We see the health benefits, the environmental benefits, the energy benefits, right?
Yes.
And even in terms of the water situation in Bermuda. And not only that, but it can create long-term jobs, provide training. There are areas for research on developing new technologies for waste energy and so on.
Yes, it
So
is.
there are really a lot of benefits to any government to pursue this waste energy technology and so
Yes.
on. So thank you very much for joining me today on this
Yes,
first
sir.
episode of the GSI podcast. We've had an enlightening discussion on waste to energy, and I hope that the audience found it both informative and also inspiring. So thank you again for sharing your expertise with us. And I would like to
Yes.
say to the audience, don't forget to subscribe to the GSI podcast so that you never miss an episode. And stay tuned for upcoming episodes where we'll explore even more fascinating topics. If you have
Yes.
questions, suggestions, or you want to connect with us, you can reach out to us at info@greensolutionsskn.com, and we'll be happy to answer your questions and connect with you. Remember, your feedback is invaluable, so please leave us a review uh, on our podcast platform. And as we wrap up this episode, I will give the final word to our guest, Calvin.
Thank you very much for having me. Basically, we just scratched the surface. We haven't gone into a lot of detail, but this can actually create a lot of jobs, a lot of jobs. People in IT, in electrical, in power engineering, millwrights. We can get civil people in, mechanical people in, because our plant doesn't just run off of maintenance and E&I and the operators. It's a large facility that needs a lot of people, air conditioning, all of this stuff is incorporated into this here. So it's not just a job. You can have a career in the waste to energy industry. And I'll leave you guys with that. My name is Colvin Manning. I am an E&I supervisor technician for the Department of Works and Engineering in Bermuda. And I've been doing this job for roughly 30 years. I was the first to start at this plant, and I'm still at it. And
Right.
I've been moving on. I've been doing a lot of stuff. So I've even started teaching. So it has taken me all over the place, and it's been great. And to see people's eyes light up and open up and say, whoa, you do this? You do that? Yes. And this is not just what I do, but this is a touch, just a taste. So hope to see you guys in the future. Thank you very much, Wayne, for having me. I appreciate it.
Thank you very much. And I'll see you in Bermuda back in the summertime.
Yes, sir.
All right.
Can't wait.
Thank you.